It has been a long time since we've been here, Caleb, but we are at Latour's Auto, and this is like old school here. Yeah, Caleb's.
I didn't know you were recording, and then I heard your.
Yeah.
You talk different when you're recording.
Do I?
Like if I'm recording, you talk the same, but if you're recording, it's like a voiceover voice.
If I'm holding the camera,
yeah, if you're
it's
holding
like the camera messes me up.
Yeah, it's been a while, a couple years.
It's been a while since we've been here. We've been doing all our stuff at my brother's shop, Uncle Jim's shop. But yeah, we're doing something cool. This thing's got a mass airflow intake air temp sensor fault, -40 on the scan tool, 5 volts on a sensor ground. I'm looking forward to this one. This should be fun. Got my specs.
How many pairs of readers do you have? Because I see you with a different pair.
7 or 8.
I can't imagine wearing those all the time.
What, readers?
Yeah.
Yeah, I mean, it sucks. I can't even go fishing anymore without them on.
Really?
No, because I can't tie a freaking hook. I can't get it in the... I have a picture I'll share with you. My friend Rob Self from Florida shared with me. Okay, so a little history on this truck. I was helping Pete and the owner over the phone. And what I was told is hesitation problems, check engine light, mass airflow code, right? But then they also had an intake air temp sensor code. And I'm like, okay, well, how's it run with it unplugged, blah, blah, blah. We did all that stuff. I guess it runs good unplugged. Had to plug it back in. I think they replaced the MAF, I'm not sure. I said, well, we have a intake air temp sensor code too, Pete. Are you sure you plugged it back in? Yes. I said, look on the scan tool, tell me what you see. They saw -40 on the intake air temp sensor on the scan tool. So I had them do some voltage measurements. They were reading, from what they're telling me, they were reading 5 volts on the signal wire, which makes sense, right? -40 degrees, 5 volts, open circuit. But they measured 5 at the sensor. And then I said, well, check the sensor ground plugged in. And they told me they read 5 volts on the sensor ground too. Now that takes care of the intake air temp sensor code. We have a problem there, sensor ground issue. But we also have a mass airflow code, and I had him check voltage on the MAF. And all of these GMs for many, many, many years used 5 volt pull down design signal circuits. So 5 volts is sourced from the engine computer, sent to the mass airflow. The mass airflow pulls it to ground, makes square wave. They had no voltage on the MAF wire either. So that's where we are. That's what I know from just phone conversations. And I have them do some other checks too that we can talk about as we go, like some circuit integrity testing. I had them ground the signal wire to make the scan tool read 250, 300 degrees on the intake air temp sensor, those kind of circuits, confirming no open in the signal wire. I'm going to show you guys that stuff. So this is going to be a really good video, I believe, on some fundamental sensor circuit testing, circuit integrity, and bypass type testing. Yeah, so we have a 102 mass airflow sensor circuit low and an intake air temp sensor circuit high. And I believe these are hard faults. You clear them and they come immediately back. Let's go to our data display, sensor data. Okay, so yeah, intake air is reading -40, mass airflow grams per second, 0, MAF is 0. Start the truck. Yeah, no mass airflow signal either. Okay, that's what he told me. So we next started doing voltage checks under the hood. That's where we're going. For you guys that aren't aware of thermistor circuits, when you have an open in a thermistor circuit, it will read high voltage and it will read very, very low temperatures. So when you see -40 on a thermistor circuit, that is a red flag that you have an open circuit. You know, whether it's an open in the sensor, open in the signal, open in the ground, that's what you have, okay? 100%, that's what we have. Let's go under the hood, do some measurements. People give me grief all the time because I'm gonna pierce these wires, just given location and ease of doing it, and I never show fixing them when I'm done. I'm gonna show that today. I know from GM's, they've used the yellow wire forever for the mass airflow signal, so that should be this one, and that should be a steady 5. I'm interested in that, but I want to see plugged in first what we're seeing on these. So guided component tests, mass airflow sensor, Sweet. All right, so pink wire is ignition voltage. I had Pete check that, and this is a battery source, ignition source. So the engine's got to be running for us to have power there. The yellow wire is the mass airflow signal. So we'll go after the MAF signal first. And black lead to a battery ground, which is under your hand. All right, so remember these colors too. The IAT is the tan or tan black, and then the low reference is tan, or the intake air temp sensor circuit. Pink is ignition, and then black and white is the ground. That'd be your MAF ground. So those two guys we're gonna focus on next. Yeah, I have no signal here at all. Do I have the key on? I think I do. Yeah, key was on. Yeah, and we should have 5 volts on this right now, and we do not. So that's a problem. Let me unplug it just to be sure. Like I said, these are 5 volt pull down designs. Unplug, no voltage. This is not a problem with the mass airflow. This is a problem upstream for sure, whether it be an open in the wiring or a computer issue. Now I'm moving to the IAT wire. So the tan and the tan black. Tan should be the IAT signal. Reading steady 5, and that is plugged in numbers 2, and then the mass, or that ground voltage is too high. Okay, some integrity testing you can do. This is something anybody can do. Go back to the signal wire real quick. Take our test light, go to a ground, go back to my scanner. See, I'm reading -40, and that's an open, that's 5 volts. So just take this, and I'm gonna touch on the probe and pull this to ground through my test light. Watch the scan tool. Weird, that only went to 75 degrees. Why is that? That should go way, way higher than that. What's the computer doing right now? That is substituting a value, I believe. So when you have that, what you wanna do is we wanna go OBD direct. In the global mode, they're not allowed to substitute data. Okay, intake air, look at this guy right here. So -40, open circuit, ground it to go full hot. It's still only going to 75. Am I grounding the wrong wire? Oh, I might be. I'm on the sensor ground, shoot. Okay, signal wire, black, white, or I mean tan, black. Okay, watch it now. That is so slow here. Went to 174. Should go higher than that. Exiting out of here. Sorry, I'm adding variables to this as I'm going. I don't mean to. Just remember that though, like these vehicles will substitute values. Okay, I'll just double check my wires here. Low reference is tan, and intake air temp signal is tan or tan black. So my probe is on my tan black wire, okay? And you can see we're reading a steady 5 volts. 5 volts on that sensor is a open circuit. We know it's open because of the ground. But if you were doing this type of testing and you weren't sure where your open was, first of all, the voltage reading tells you that you don't have a problem between the computer and the sensor, because the computer is the source. But we can look for a reaction, and that's simply by grounding this circuit. I'm using my test light to do it, and you see I dropped this voltage down to 0.46, not a complete ground. Let me check my test light here. I should be able to ground this all the way. Okay, now my test light's adding some resistance to it. So we're not totally grounding that circuit at 0.35. And then what you can do is look at your scan tool. You see the reaction of the intake air. We're now at 180 degrees. If you fully ground that circuit, it would get even higher. My test light's adding some resistance to it. But it's an integrity test you can do on these sensors, grounding the signal, opening the signal, looking for reaction. Clearly we have an issue with our sensor ground. And I say clearly because watch, when I measure it, moving this over to the sensor ground circuit, see my sensor ground's at 5 volts too. And then we have no signal on our MAF, which is our yellow wire. So what I want to do is follow this harness and look for rodent damage. And it's possible that we have some, just given the way that looks up there. See the fiberglass insulation, and then back there too, you can see it, like all in that back area. So the harness runs where my hand is, then goes underneath a lip down here, runs across the inner fender and then up to here, okay? And then follow it over, and right where I was talking about before, in here and back in here, you see it looks like rodent stuff. Look right there. And I'll bet you $1,000 that we have a broken yellow wire right there and a broken tan wire. The yellow wire is a mass airflow signal. Tan wire is the sensor ground circuit for the intake air temp sensor. So there's your broken yellow wire, you can see. And then one of these tans is the intake air temp sensor ground. Solid tan, then white, and a purple. But I did say $1,000, didn't I?
You did.
There's your two wires. What these other circuits are for, I don't know. We didn't interrogate the rest of the system. I only went after the engine computer, but we'll fix them all. And before I forget, if you have a scan tool, maybe you have a minimum function scan tool and you can't read a data parameter for, say, the intake air temp sensor, what you can do is, you're reading -40, what you can do is short that sensor out, pull it all the way down to 0, clear your codes, reread them. Remember, we had circuit high codes before, and what you can do is you can set circuit low codes when you ground it. And what does that tell you? If the code changes from high to low and you read the code, it tells you that your circuit integrity is good, computer to that component. So that's chapter 10 material for you guys following along, signal circuit integrity testing. I cover this stuff extensively. And this is the foundational, fundamental information that we're talking about here that applies to everything. I just had a guy the other day who works on forklifts. Same thing, same 5-volt reference circuits. Pretty cool stuff, universal. And that's where we're at. This is an easy catch, and this sensor was replaced. It did not need to be. I believe it was replaced by the customer. And this is another example of why you want to pay for diagnostic work. I mean, this will be cheaper than paying for a mass airflow sensor. Never needed one. Voltage. So reading 5 on my signal. That was the intake air temp sensor signal. This will be the mass airflow signal computer side. This should be 5. This should be 5. There it is. 5 volts. That's what we wanted to see. The IAT. So which one's which here? Because I don't want to mix these up. It might be a shared circuit. That one's 0. That one's 0. Let's see what these guys read. That one's 0.1. This one's going to be 5. So that's my intake air temp sensor ground. Which one do I connect it to? And what does this go to? Let's do a full scan because I want to know what else is not working. Let me clear these codes. We definitely have other circuits that aren't working. That's weird that I'd get 0 engine codes right now. I guess maybe I need to start it. So in the HVAC system, I have some temperature control feedback codes. Tire pressure, passenger seatbelt tensioner, theft deterrent. I should have run this first. I just don't want to hook the 2 tan wires. I think they're probably both sensor grounds. I just don't know what else is there, and I don't want to mix them up in case they are different. I'm going to start this real quick and see what codes we set. Yeah, it doesn't even want to run. Normally these have pretty good backup strategies. Code scan again. Why is it not setting any engine codes? That's why it's not running. It's not recognizing this fault yet. I'm interested if this tan wire. All right, so I'm just seeing where this is shared, if at all. Okay, so it's not. It's a low ref by itself. I don't want to mix this up. I want I want to make sure I have it right, but I want to know where that other tan wire goes. It does split, and it comes over this way. No tan wires there. Does not go inside like I thought. So the HVAC system is maybe not on here. Okay, it goes down underneath. O2 sensor maybe. Like I got 2 freaking gray wires. Okay, let's do something a little unorthodox. I'm gonna go battery positive with my test light. A sensor ground will light my test light, and I'm not gonna hurt my engine computer doing this. Okay, harness side. If they both light it, that one lights it, and that, oh damn it. I wanted one to not light it, so they're both showing me a ground. What's the second gray wire? I want to know what that second gray wire is used for before I connect this. I don't think it's HVAC, so I don't think it's that one. Disabled information stored, invalid serial data message received. So I almost need the engine running longer because I'm not setting engine codes. Let me look underneath. Okay, so oxygen sensor here. This is my downstream, and it comes across the frame up to. You see me pulling, tugging on that right there, right? That's the downstream, and then the upstream is that connector. It loops over, goes that way into the exhaust. So we have 2 oxygen sensors feeding up into this leg, and that's where that other gray wire or tan wire is. Okay, so I feel better about using either gray wire because of that, but let me go back and show you guys the oxygen sensors. The reason we don't have an O2 code is somebody was in here, cleared them, and we never ran it long enough for it to generate that oxygen sensor code. But if my O2 sensors show me tan wires as the sensor grounds, then we're gonna be able to use either one. So this would be bank 1, this is gonna be bank 2. The bank 2, sensor 2 has a tan wire, and anytime you see low, that's a sensor ground. So that's a tan wire for that. It shouldn't matter at all. I can use either one, but I wanna show you guys something that might be really cool. So we'll go back to our engine. We'll pull up our data. I'm very much interested in what my sensor data looks like on bank 2 for the oxygen sensors. Now we can fix the other ones first, get it running, and then I'll be able to tell which sensor, because sensor's cold. They're all showing us a bias voltage right now. What I was thinking is, I believe all the sensor grounds are shared internally. I realized I could do a resistance measurement from the engine computer and figure out which pin it is. But that's a real pain in the butt on these with those connectors. I'm just trying to think of an easier way to prove which one is the oxygen sensor signal circuit, which one is the IAT sensor ground circuit. I'm just not sure that I can, because they're both grounds. I can tell you guys which one the O2 is and which one the intake air temp sensor is, but on this side. But that's not gonna help me on this side, because these both go to a ground on the board. So in this case, we're just not gonna worry about it. I'm just gonna connect them because they're sensor grounds and they're both sensor circuits on the engine computer. It is not gonna matter. It's not gonna matter. If I have any evidence whatsoever in length of wire, I kinda do. See how that one's longer? Mm-hmm. That one's shorter? Mm-hmm. See how that one's longer?
Yeah.
And that one's shorter? Oh, there we go.
It's good enough for me.
That's good enough for me too. Longer one on this side to shorter one on that side, right? Remember that. I'm going to the shorter one on this side with the longer one here.
Okay.
Oh my goodness. I need something to lay on. This is awful. I'm literally gonna lay down. I'm gonna lay down.
I just won't show on camera how you're...
No, go ahead. Go ahead, show it up. This is, now I'm comfortable. I can't reach it. It's like the wrong... No!
Come on!
Guys are like, you should only solder and heat shrink. Okay. I'll take note of that for next time. I don't think we need to show all of these.
No, I'll just get a couple shots and then we'll cut to after it's done.
Because then I can MF things at will.
Yeah, you can.
These are the sealant type crimp connectors I'm using.
Mm-hmm.
There's a goo that once you heat them up, it helps seal out any moisture. All right, we're gonna get the rest of these done, and then we'll get a shot of us heating them up, and then we'll get some voltage readings when we're done and call it a day. You haven't used this before. We'll try it.
I think I remember you trying it one time and hating it.
Did I hate it?
Yeah.
Yeah, I guess we didn't like, maybe we thought it got in the way.
Yeah, it's kind of like inconsistent.
It's burning me. Yeah, I think I remember trying to use this and just not liking it. We like the flame by itself.
Just use your hand as a heat shield.
Nope. Uh-oh. As far as the sensor grounds go on this, sensor grounds are generally shared. They have been forever. Externally from the computer, where you'll have a splice pack and sensor grounds are all shared. So I have no problem doing what we did. Even if I got the two grounds mixed up, I have no problem with it at all. Okay. Now before we finish that, let's start this up. Starts and runs and stays running. We'll watch our bank 2 sensor 1 and our bank 2 sensor 2 oxygen sensors. We'll make sure that those are warming up. Yeah, see the bias voltage dropping down real quick. Perfect. That's what we want to see. If you guys want more info on bias voltage on oxygen sensors and what I'm actually referring to right here, which is called a time to activity test, I got a ton of information. Chapters 4 and 5 right here on YouTube on a playlist. You want some classroom type stuff, go over to the website, sit in on some classes, and we'll talk about this. I'm comfortable with those O2 signals. That looks great. Our intake air temp sensor looks good now. And now we have a mass airflow grams per second reading, which we did not have at all before. All right, let's show you some manual tests. Go back to our scope and get this connected back to my yellow wire. Should be a digital signal. Yeah, there you go. A little bit of a kind of curve to these signals, but that's pretty typical. As the RPM changes, that frequency is going to change. So I'll just go in, snap the throttle. I'm not going to be able to see that at the same time, but what you're going to see is those square waves are going to get real tight. Watch. Digital type mass airflow sensor. This is a design GM has used forever. And then I'll get you voltage on the intake air temp sensor, which was the brown with a black tracer. And that's my voltage signal. Some noise in there, some hash in there, just because we're using a lab scope on a really small time base. There you go, 1.8 volts. We didn't see that on scan tool, we just see degree Fahrenheit. But that's good, that's a fix all the way around. I'll just clear the codes out. We didn't have any engine codes anyway because someone did before. And then what's left to talk about with this one? I think that's it, man. Learn your fundamentals. That's key. I was able to help them only so far over the phone. I said, okay, you got 5 volts on your sensor ground. You have an open in either that sensor ground wire external to the computer, or you have a computer problem. What led me to think that we had damage in the harness is we also had 0 volts on the mass airflow signal wire that's supposed to be a 5 volt sourced pull down circuit from the computer. So we had 2 opens, and I just felt like that suggested a harness issue, and it sure was. We have rodent issues. We're gonna have to tell the guy about that, and he's potentially gonna have other issues with this truck on where he parks it. He's gonna maybe have to take some steps with that. I heard like peppermint oil, some different things you can spray under the hood. The best thing is one of these guys, right?
I'm gonna put in the video bean puking.
I was thinking the picture you have of Bean where he looks all majestic sitting in the yard, like that one. So you need one of these guys for sure. We haven't had any issues at home, and we have, you know, 4 cords of wood sitting in the yard all the time, and all kind of vehicles parked there, and never have rodent issues when you got a cat. So that'd be the recommend too. Recommend getting yourself an outdoor cat. Oh, I guess last thing, I said I was gonna fix these. Let's do that. The hard part about this, using this, look how small.
Oh yeah, you can't even
Look how small the holes are.
Don't move.
Like, they're so tiny that you almost don't even need to.
Yeah.
Like, look at the nails on the tool itself.
Yeah.
But let's do it anyway, huh?
Yep.
Oh, this stuff's all dry. Oh, that sucks. Dude, it shouldn't look like this. It's all dry. I mean, it's been sitting in my truck for a while, and yeah, be all right. People are gonna be like, that's such a hack job.
Yeah. Who cares?
I just need to put all these harnesses back. I'll handle that part off camera. I hope you guys learned something from this. You want more training? Stay right here with me on YouTube. I got playlists right here that match the chapters I was referring to. Chapters 4 and 5 are my oxygen sensors. Chapter 6 is my thermistor circuits. Chapter 12 is my mass airflow. So there's playlists right here on YouTube that are listed by chapters like that. That's the chapters that are listed in my book. And if you want more training, you want to sit in some classes, you want to learn your fundamentals, come join me at ScannerDanner Premium. That's on my website. Still only 11 bucks a month. We got 530 videos and counting, with 250 of them being literal classroom settings where I'm teaching my course to my students, recorded it. It's right there for you guys too. So thank you guys. We'll see you next time. Everybody always gives me a hard time.
For what?
What are you doing?
I'm waiting.
Well, I'm talking.
Okay. Yeah.
I know we haven't done this in a while, but so everybody gives me a hard time about piercing. We're gonna use Phil's today. Can we not say that?
We can't.
Are you sure?
Yeah.
This is probably going on the paid part of the site, so we couldn't use it.
I still gotta censor it.
So, I'm sorry, Phil. We're using
the stubby probe.
We're using Phil's small probe today. Come on, I can't even do this.